You can get a good view over here. It's starting to fail on this side. You want to see that side over there?
Everybody, welcome back. Today we are at DDS Engineering in Bowling Green, Kentucky. This is actually my dad's company. They've been here in Bowling Green for about 50 years now, and they do everything from soil and concrete testing. It's a civil engineering firm, land surveying. But today we're going to get them to break some lumber. So stay tuned, and we're going to check out, we're going to do some destructive testing of some beams that we've built. So hey, we're back in their concrete testing lab, and we've got Alex and Matt and my dad Dennis back here because everybody wants to see destruction, right? And we're hoping that we see splinters and shards of lumber go everywhere. But what we're doing is we're gonna try to test a 6x6 treated post against a 3-ply 2x6 post. We'll wind up testing the 2x6 in both orientations with it standing vertically, so we're pressing the 5.5 inch direction, as well as laying flat where we're pressing it in 4.5, right? And but what we're gonna start with is the 6x6, and this is a concrete break. Who wants to tell us more about a concrete break? They're all takers, look at this.
Grab on, Alex.
Sure. What do you want to know?
I don't know, just tell us generally what you guys do with this thing, besides break lumber.
So on most job sites that we go to, you have, you know, major components, concrete, and an engineer designs concrete with a specified strength. The way we know what that strength is we sample cylinders on site. And then we bring those cylinders here and we break them in this machine to determine how strong that concrete is.
So just like when we order 3,500 PSI mix.
That's right.
That's what you're trying to determine is, was it 3,500 or was it 2,500?
Right.
And an utter failure. And this is a cylinder right here like you're talking about, right?
Yeah, that'd be a
That's
6 by 12 inch cylinder right there.
So they sample those cylinders in that plastic sleeve that you see in the other one and bring them back here in the lab, and you do 3 breaks on them, right?
Well, just as many as you want, but the goal is usually we do a 7-day break to see where it's tracking to. And if it's a 3,500 mix, it should hit 3,500 around 28 days. So that's usually the final hit. Well, that's around 28 days is when it peaks, roughly.
And did y'all used to do though a 24-hour break? I was thinking that y'all used to do 23 breaks.
You have a 24-hour mix and you want to see what the strength
Gotcha.
is 24 hours. Yeah.
So somewhere between 2 and 3 breaks on it.
Right, but you only get 1 break each cylinder, so
yeah, you gotta have multiple
experiment.
samples. All right.
So this setup is typically set up for flexural strength of concrete, determine the modulus of rupture. So concrete's really good in compression, not so good in tension. Jason approached us and kind of wanted to do this setup, so we're going to test it and see how it goes. So it's got a load rate of about 2 to 3 psi per second. That's the standard we have to break it at for concrete beams.
Gotcha. So what is our reading right now? You're like where it says 1,500 pounds. That's actually not PSI.
Correct. That's pound force that's applied there. This, the L and the H, is the bracket on the pace rate. So if we get down here to low, we'll bump that pace rate up a little bit. But I suspect that we're going to be, it's going to take a while to break this. I suspect we're going to be up to the, 78 to 90,000 pound max load.
Really?
Yeah.
And the PSI would actually be greater than that, right?
Yeah. Yes. That's going to take too long.
What we should have done is set up a dial indicator on it.
Yeah.
And started monitoring the
We can do
deflection.
that. You want to get that CBR set up?
Because that's what I was looking at, to see if I could see any deflection at all. Put a dial indicator on there and see how much it starts deflecting.
where's that come from? Didn't it?
We're working on that.
Here, Josh, look, here's a cylinder. That one we looked at earlier, it's cast in 1967, right? So where'd this come from?
When we were working on CSX siding at Cave City, we found that under the bridge, Highway 90 bridge over CSX railroads. That's where they pulled the cylinder on that bridge.
A long time ago. Wow. So you resetting or are you still braking?
We're still braking. We're gonna adjust the pace rate for the next one so it doesn't take forever.
I can't visibly see any reflection.
It's not even 10% load that's gonna tell you what I'm looking at now is our apparatus. It's not gonna take that kind of load. Blueprints.
Mm-hmm.
Maybe that glue. Could be. I think it's that glue quality.
Really?
Yeah.
And see, the glue will actually, the glue will probably not come apart. It will rip the fibers of the wood apart.
And maybe what it's doing is
No, so we've actually got a crack here in the end. Right here in the end in this outside one, we've got a crack right there.
Yep.
Another one right there. Another one down there as well.
So this is just like a liquid.
So right now, guys, we are at 15,300 pounds.
So Matt, you had said you had that function where when it sensed that failure, like stop or whatever, is that turned off right now, or is that still on?
No, it's not. We can adjust that.
So it's actually braking so slowly at this point that the machine's not even really sensing it.
Right. No, so what, if we've got a cylinder set up, we can say, okay, if we're climbing, the stress is in climbing, and it's got a great decrease in stress, say 20 or 30, even up to 50%, then it'll cut it off. But if it's got a slight drop of like 5%, it'll keep on going. Yeah, you can see the bending on that opposite side over there.
There's more
Yeah.
failure and everything here than we had. Is this thing checking out too?
Man, I really hope those 6x6s are
See, look here. Look this end, baby.
Oh, yeah.
It's still following the grain pattern and some spots in there that
Against the grain. It's a really good restaurant. They sort of laugh at that.
And it's actually starting to crush it on the rollers now.
Yeah.
Yeah, pretty big time.
Flatten the strokes real good. Quarter of an inch.
Yeah.
Yeah, I mean, look at it right there. Has the crew gone over to Becky's yet? Dakota? Okay. You kick me. You kick me. $22,000.
We got a lot more happening now, don't we?
Mm-hmm.
Slide through there.
That was separate there. Blue joint.
It looks like it.
Yeah. You gotta get separation of the blue joint on this.
We may have to do something. Hand me a straight edge, please.
Yeah, so that right there is separated pretty good. You can smell that really too.
It's heating it up.
Oh yeah. Yeah, that joint right there is separating. We got an absolute ton breaking apart on there.
So what are you looking at there, Matt?
I'm just the max piston stroke. We don't have much, not much play left. Oh, you can really smell it now. Yeah.
Yeah.
Working energy to heat. You better watch it. I was bursting in flames over there.
That would be awesome.
Yes, it would. I'll take a random sudden burst into flames over an explosion. That's how I felt for the first half of the day.
Looks like there's a knot right there as well where it's starting to like come off of.
You got about 16th, Dennis.
Now you probably get the belt where you go have to hot lift.
I'm gonna have to cut it off. Ah,
What did it do?
piston stroke.
Oh, did it? Like about 2 seconds getting it quick enough, right?
I was on it. I was getting ready to move it back. Let's see. Well, there's some good shots there.
Yeah, man.
Quite a bit.
Good lord. Starting to
Where the
come,
glue lamb is
yeah.
right there.
Table where you get a shot at it.
Yeah,
Yeah, I'm
starting to come
this table.
across there, and right next to that knot was where it was starting to try to fail.
Smell it, can't you?
Sure can. I'll toggle it up and down. Make sure we don't have
Smell that liquid nail.
Yeah. Did you see what the machine was at pounds wise right before it failed?
It's cut off. I'm gonna guess gonna guess about 30,000 pounds.
Because the last time I looked at it, it was right about 22, but that was a minute ago, so.
I'm gonna guess about 30,000 pounds. We can hook it up.
All right, we're back. We made some changes to the machine. A little bit of sizing difference. We're gonna do the same one again. We're gonna see if we can take it to failure.
So you're like preloading it?
Yeah.
Did you hear it pop when you walk out
So
of
it's
the
actually
room?
splintering out
Mm-hmm.
here now.
Failure in the middle there. What are you reading, Matt?
18,000.
Of course, we lost all the strength from the first
Yeah.
It's separated right in the middle now.
That's
That
fair.
is definitely failure.
Yeah, let's cut that off.
You know where that's at right now? Because I mean, we've got like this outside ply is almost all the way to 2.
Alex, 43, 43, 1.
All right, so anyway, hey, here's what we've got. Here's what we're testing today is a traditional 6x6 treated post versus the 3-ply laminated 2x6. These are just laminated up with traditional subfloor glue, like liquid nails type product, and nailed together to hold it while it cured. And we're gonna test the 2x6 column in both this orientation and laying down flat as well. And of course, we expect that we'll see a fairly significant difference when we lay it down versus in its upright orientation. And our anticipation is that it's far beyond what the 6x6 will do. So we're gonna see. So I'm here in the lab with my dad, Dennis. And so how long have you been doing this?
Next month, we will start our 49th year of being in business.
Well, I said 50 out front. I'm close.
Pretty close.
And pretty close to 50 years you guys have been here in Bowling Green. And when did you start the materials testing? Because that really started with survey and engineering work at that time, right?
Materials testing, I guess, mid-90s, mid to late 90s. So we've been doing this for 25 years.
Because we built this building in
We've been here
06 or 4, what was it?
Yeah, we've been here about 14 years.
Okay. And the lab was fully set up at that point and at that time. So.
Yeah, and we built it as a dedicated lab when we built this building.
And then today, we're just trying them to see how good they are, whether they can break wood or not. Never broken wood, right?
Well, broke a lot of concrete.
You don't know what they've broken back here that you're not aware of, right?
Yeah,
Because there's a lot of stuff could have gone in that
balls,
press.
Who knows?
Yeah, they just won't own up to that. But anyway, so this is my dad, and this is his place, and been doing this a long time. So we're gonna get back to breaking some lumber.
You can actually see it opening up.
How does this compare to that concrete tank? I'm just meaning like as far as overall strength. I mean, what is
Oh, that's higher.
Yeah, the wood is.
Yeah.
Compressor.
When you bend, you have aspects of compression and tension. Since that's got, when we engineer stuff, we actually simulate zero tension, just so small comparison.
What are these beams you are testing? What are they for?
Those are the tilt-up panels. So there's a job in down in Franklin, or Nelsonville.
Any tilt panel wall construction, that's what I made a lot of things in the
There are four of the walls flat on the ground. Really lifted it up. When they did that, they had to move it to concrete straight. They wanted to make sure it had a little touch of thing to have hold on to it.
It's really stuck right on the same metal. It's sitting.
Yeah, I'm gonna cut it off, guys. Or it had already, it was going past that line here.
The bottom line though, where it's sitting there at 27,000 just fluttering, it's really thinking it's done. I mean, it's reached a point where its next big move is breaking it in two, right? Okay, so where we got to today, and they're gonna have to, it's lunchtime, they're gonna have to go do something else, and we've got to kind of make some adjustments to the machine because we're just running out of stroke, and so we're gonna come up with some different shims, but we broke this one. This ended up, we don't really know. We're gonna have to reset some things and rerun this, but this one wound up at about 30-something thousand pounds, right at 30,000, but that was on a 2-part test and it's not super accurate, and this one wound up topping at about 27. So they're pretty similar, we think, and the main thing is, you know, my guess is that these are actually stronger, but we'll see, and we're gonna wind up coming back another day to try to finish these things off and really get them broken into and see where they really wind up at. And we didn't get to test this one in its flat orientation yet, so we'll do that. Hopefully sometime next week we'll get back over here and be able to break some lumber.